RD Sharma solution we are taking. This is the chapter probability, and the exercise we are taking is fourth exercise. A coin is tossed thrice. Now there is a coin. Now you know that coin can give either head or a tail. Now 3 times a coin is tossed, or 3 coins are tossed at once. All the 8 outcomes. Now from where this 8 has come? Now it follows a proper mathematics. One coin can give you how many results? It can give you either head or tail. Only 2 possibilities are there. And how many coins are there? There are 3 coins. So 2 to the power 3. That is how these 8 outcomes have come. Are assumed equally likely. That is, head can also come as tail. So both have the 50-50% chances of coming. Now each of the following cases. Which of the following cases? Events A and B are independent. What does independent means? So you are making lunch. Your neighbor is also making lunch. Now these 2 are independent events. That means the lunch or the breakfast or the dinner made in 2 houses which are neighbors are independent to each other. But the lunch and the dinner may be connected of your house. So single house, the lunch and dinner may be some dependent event because you might be using some content in your dinner also. So independent means no relation at all. Dependent means interdependent. Let's understand it mathematically. So we have this event and this is the other event. Now there is no commonality. They don't intersect. They have no area which is common. So they are independent. Now the coin is tossed thrice. How are we going to write these? Now you have understood about this HHT, THH like this. But the idea of writing it, because there are 8 possibilities, that I am going to tell you just now. So first write HT one by one. So this has to be 8 of them. So HT like this. Alright. Now make this H twice and T twice. The last line has 1H, 1T. Here we have 2H and 2 T's. And one by one. 2H, 2T, 2H, 2T. Now make it as 4. So it goes in the power of 2. Now 4H and 4 T's. 4H and 4 T's. So these are the sample space, that is, the coin is tossed thrice or 3 coins are tossed at once. The sample space remains the same. So this sample space I am writing H, 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 head, head, head in 3 coins, head, head, tail, head, tail, head, head, tail, tail. Now I will always suggest that don't write these in one line. Make it as 2 line or 3 line. It will make your task easier. So tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. So these are in all 8 possibilities. These are the sample space. So this comma and round brackets are essential. Now A event is the first throw results in head. So before obtaining the probability, we will make the set. How are we going to make the set? The first throw result in head. So all the sample space content or the experiment where head comes first has to be taken. The first throw results in head. So all these, the top line you can take because all of them has head. So let's make the set first, then we will go for the probability. Basically we have to find out the number of elements in this A. So I am writing all the elements from the sample space which have head at first. So head, 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 tail, head, tail, head, and head, tail, tail. Now number of elements in A will be what? 1, 2, 3, 4. 4 are there. Now probability of A will be, now probability is number of the favorable cases divided by total number of cases. That is, the numerator will be what do you want, what you are expecting. Denominator will be what all is expected. So the probability will be 4, which is the favorable cases, and the number of elements in sample space are 8. So 4 by 8. Now coming to B. Now B set we will make last throw result in tail. So whatever comes in the first or second coin doesn't matter. The last should be tail. So take all the elements which has or all the content experiments of the sample space where you get tail at the last. So we have taken 4 again, 4 values again from the sample space. So what is the number of element in B? 4. So probability of B will be what? Number of favorable cases are 4. Total number of cases are 8. So 4 divided by 8 it is. will be both of them are half, 1 by 2 and 1 by 2. Now in order to prove that these two A and B events are independent, we have to use an equation or equality. That equality is PA intersection B. So when we have probability of A intersection B, if it is equal to probability of A multiplied by probability of B, when you multiply these two, if it becomes equal to probability of A intersection B, then they are independent events. What is P and PB? We have already computed it half and half. So multiply these two, half into half is 1 by 4. Now P A intersection B. So let's find out A intersection B. To find out the common elements from A and B. What are the elements which are common? HHT we are getting. See, HHH and TTT you will not get. These two, that is HHT and HTT, you are going to get common. That means you have two elements which are common in A and B. So number of elements in A intersection B is 2. Probability of A intersection B will be number of favorable cases, which are 2 in this case, and total number of cases which are from the sample space, which is 2 by 8, which is 1 by 4. So 1 by 4 equals half into half, 1 by 4 is equal to 1 by 4. That means these two events are independent because left hand side is equal to right hand side. Now this is how you need to do it. I will encourage you to write this set first. Once you make the set, then you can go about doing all these. And finally, PA intersection B equals to PA into PB. AB are independent events. A coin is tossed thrice and all the 8 outcomes are assumed equally likely. In which of the following cases are the following events A and B are independent? Now these questions, that is the first question 1.2, 1.3 till these 3 questions are similar. So we'll make this HT. I told you how to make this sample space. So then we have twice of H, twice H, twice T, then H 2 times, then T 2 times, then H 4 times and 4 times T. So when we write this, it will be easier for you to get the A and B directly from it. So now this is, you can assume it to be a single line, but I have written this because it will make our life easier. You'll see just now. What is the number of element in the sample space, which is 8. Total number of cases will come from the sample space only. What is A? Number of heads is odd. So the highest number of heads can be 3. The lowest number of head can be 1. But we are not able to choose 2 heads. Why? Because it is even heads. So 1 and 3. So just I am taking all the elements of this sample space where we have either 1 or 3 heads. We have HHH, HTT, THT. You can count number of H. This will be either 1 or this will be either 3. So we get 4 elements out of the sample space which are confining or abiding the number of heads is odd thing. Now number of tails is odd. Again, T should be equal to 1 or T should be equal to 3. We cannot have T equal to 2 because it is going to be an even number of tails. So we'll take again this from the sample space. Now count T. Wherever you get 1T or 3T, just write it here. So I'm writing HHT, then HTH, followed by THH, and then finally TTT. So now you see how easy it has become when we are writing in this form. Number of elements in B will be what? 4. Now next thing is the probability of A intersection B we will compute, and if this equals to PA into PB, that is 2 probabilities PA and PB, if we multiply them and it becomes equal to the probability of A intersection B, we'll say that they are independent, otherwise interdependent or not independent. So PA is what? Number of favorable cases will be what? 4. PB, number of favorable cases 4. PA intersection B. In all of these 3, the sample space has 8. So total number of possibilities are 8. So I'm writing 8 in the denominator for all of these. Now PA, number of elements 4 here. Favorable cases. PB, favorable cases 4 by 3. PA intersection B. Now find out A intersection B also. This has to be done simultaneously with SAB, and this A intersection B has to be done when you are doing all this. So what is the common elements between A and B? So we have this. There is one slight mistake actually I have committed. The last of B is not TTH, it is TTT. So there was a mistake. I am now taking care of my mistake and writing it as TTT. So now you see the commonality. There is nothing common. You will get a 5. There is no commonality between A and B. So the A intersection B is 0. Number of element in A intersection B is 0. So this PA is half, PB is half, and P intersection B is 0. So do you think that half into half is equal to 0? No, 1 by 4 is not equal to 0. That means these events are dependent. They are not independent. They are dependent. So this is how we are going to go about it. Writing A and B and A intersection B set is mandatory. Now sample space again, same thing. It's just a repeat telecast of what we have seen. So head, tail, head, tail, head, tail, head, tail and head, tail. 8 times head, tail you write. Now 2 times head, 2 times tail. 2 times head and 2 times tail. Now 4 times head, 4 times tail. So this is going in the power of 2. 1h, 2h, 4h like this. So this is the sample space I have written. A coin is tossed 3 times. That is, this is the whole sample space for this one. Number of elements in the sample space is 8. Now A is the number of heads is 2. A is number of heads is 2. So you have to see wherever you get 2h, just write it here. So H, H, T, H, T, H, T, H, H. Only 3 will come. So number of elements in A, if you count these elements, these are equal to 3. Now coming to the B. The last row result in head. So this we have already done in the previous 1.1 I guess. Just take the head and fix H at the last and take all of them. H, 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 T, H, T, H, H and T, T, H. So these are the number of elements. So number of elements in B, if you count them, these are going to be 4. Now A intersection B also we will compute here or evaluate here. A and B, whatever is common, just write it here. So what is the commonality about which elements are common here? HTH is here. So write HTH and THH is also there. So THH and HTH, these are 2 commonality. So number of elements in A intersection B comes out to be 2. If you count the number of elements in A intersection B, it is going to be 2. Now probability. Probability is simply the number of favorable cases divided by total number of cases. So if we have PA intersection B equals PA into PB, we will say that these 2 events A and B are independent. Otherwise, they will be dependent. So PA intersection B, denominator of all these 3 will be 8 only, because the probability is favorable cases divided by total number of cases. So 8 will come in the denominator. A intersection B, number of element is 2. PA, A element, number of element is 3. PB, it is 4. Now multiply the right hand side, you are going to get 3 by 16. And what about the left part? It is 1 by 4. So 1 by 4 isn't equal to 3 by 16. That means these 2 events are not independent, or in other words, they are dependent. Alright, I hope you got the idea. You can just write they are interdependent or dependent. That is, if you have 2 sets, there is nothing common, there is no overlapping, there is no common area, we can call it as they are independent, otherwise there will be some dependency. So this is how this will be done. Again, I am reiterating: sample space, set A, set B, and intersection A and B. These 3 sets are very important. You need to write them, then only you will be able to do the exact calculation. So this is all about now. We'll take care of other questions later. Thank you so much.